next question is, what is meant by homologous series? Right, the first four members of homologous series that begins with question number A and B is given to us. Now let us first try to answer the first part, that is homologous series. Now basically, homologous series, it is the series of organic compounds that have the same functional group and similar chemical properties, but differ by CH2 group, okay, CH2 unit, clear, in their molecular structure. So basically homologous series are nothing but they are belonging to the same family, okay, they are belonging to the same family, only difference is they differ by one CH2 group, clear. That is basically you're going to write down all the members of that particular family. So let us take one example in order to explain this topic. The first one A is given to us is CH3CHO. Okay, so they have asked us to write down the first four members of homologous series that begins with this particular group. Okay, so this is the first member. Okay, this is the first member. Now, first we need to identify what is the functional group present here. The functional group they have given is aldehyde. Okay, so if this is the first member, the second member will be containing one more carbon atom, isn't it? So I'm going to write down this CHO, 2 carbon, and then the second member will be containing 3 carbon. Clear? Same way, I'm going to keep on adding one carbon atom. So basically, I'm adding one CH2 group. Okay, I will keep on adding one CH2 group. Then the third member will be, this is the second member. This is the third member. Your CHO. Then this is carbon, carbon, add one more carbon. And then the last one is, fourth one will be, I'm going to add CHO. This is 1, 2, 3, 4. Clear? So in the first member, I can see there are 2 carbon. Second is 3, then 4, and then 5. So basically, you're going to keep on adding one CH2 group, or in the other words, keep on adding what? Keep on adding the carbon atom. Now I'm going to quickly balance the structure by adding the hydrogen. So here it is, how many hydrogens are needed? Here CH3, this is CH2, same way CH3, CH2, CH2, same way. The last one you are going to add CH3, this is CH2, CH2, CH2 and CHO. Clear? When I talk about the naming, quickly we are going to write down the naming. The naming is, now they have asked us to, okay, write down only, okay, they have asked us to write down the general molecular formula. Now the molecular formula is already written. Now let us write down the naming. The name of the compound is acetaldehyde. This is acetaldehyde. The second one is 1, 2, 3 carbon. So we call this as a propionaldehyde. All these are common names. Okay. Total 4 carbon are present in the third member. So this will be called as butyraldehyde. Okay, this is butyraldehyde. And then the last one, since 5 carbon are present, the common name is Valor, and then you are going to add aldehyde to it. So it becomes valoraldehyde. Valoraldehyde. Clear? So this is everything related to homologous series, and then the first 4 members of the homologous series starting with this structure. Now let us quickly apply the same trick to the second one and try to solve the second as well as write down its naming. So you can just quickly take a screenshot of this, or you can simply pause the video, Try to solve it on your own and then you can cross check the answer. Now coming to the second one, it is CH, triple bond CH. Now this is the first member, right? Now coming to the second member, definitely in the second member, I'm going to what? I'm going to add one more carbon atom, right? So I'm going to write down this group as it is. Okay, this group as it is, I will write down. So this is C triple bond C, H. You add one more carbon to it. Okay, lastly, I'll balance it. Then for the third one, it is the C triple bond CH. I'm going to write down as it is, this one carbon, and add one more carbon. And in the fourth one, fourth member, this C triple bond C, then this and one more carbon. Okay. So like this, we are going to keep on adding the carbon atoms for every member. And then lastly, I'm going to balance it. Now, do not forget, always remember now, many students, they make mistake while writing this structure. They simply put the CH as it is. Okay. Suppose if I put here CH, then is it, the structure, is it balanced? No. Okay. I cannot put one carbon if there is one hydrogen. So you need to remove this hydrogen. So for a better understanding, you always write down the carbon skeleton first and lastly you balance it with hydrogen. Clear? So now here there is one more carbon. Okay, now quickly we are going to balance it. This is CH3. Okay, this is CH3. Here we have CH2, then CH3. This is CH3. This is CH2, CH2, then again here no hydrogen, okay, because already the carbon is balanced, so no need to put hydrogen here. So this is the structure, okay. Now let us quickly write down the namings. The naming is not asked, but still you should know the naming. The first one is ethine, okay, or we can also call it as acetylene. The second one is propine, or we can call it as a methyl acetylene. Okay, this is the methyl group and this is acetylene. Clear? Coming to now the third one, it is 1, 2, 3, 4. We call it as a butane. Okay, I am not putting the position because the position, it is what? First position for all the examples, for all the structures. So it is not mandatory to write down the first position. And then the last one is pentine. And then the common name for pentine is, this is the acetylene group. Okay, this is the acetylene group. And then the 3 carbons are left. So 3 carbon means it is what? It is propyl acetylene. Clear? So this is how we are going to solve homologous series type of question. Now, in order to write down the general molecular formula, let us take C. Okay, we have carbon, hydrogen and oxygen. Okay. Now, let us look into carbon. The first example, we have 2 carbon, hydrogen it is 4. Clear? So what I can do is, I can just make one formula from this. This is CN. If I am having if I am having 2 carbon, then the hydrogen is twice of that. So basically, I can write down CN and H2NO. Clear? This is one of the form you can write down. Or I can also write it down in the form of CHO. So CHO, I'm going to write it down as it is. If I'm having one carbon, I'm going to focus only on this group now, because CHO as it is, we are going to write down. Okay. Now over here, if I have one carbon, then how many hydrogen we have? So I can write it down as, okay, so 2 ones are 2 plus 1 it is 3. Same way, let us have a look on this one. We have a C. How many carbon? 2 carbon we have. And hydrogen, it should be 2 into 2 plus 1, 5. Okay, so it should be 5. So is it 5? Yes, it is 5. That means this formula, it is what? It is satisfying. So what I can do is, I can simply write down the formula Cn. If I am having n number of carbon, then hydrogen, it should be 2n plus 1. And then of course the CHO will remain as it is. So this is how we are going to derive the molecular formula from the given example. And then it belongs to which class? It belongs to aldehyde class. Okay, the name of the class is aldehyde. I hope the entire concept is clear to you.